Now we have seen some important points on three-dimensional geometry. Now our next and last important point is that angle between the two lines. Angle between two lines. Angle between two lines. Now we have seen examples, so many types of, such that direction ratios, direction cosine. If there are two lines in three-dimensional geometry, then what will be the angle in these two lines? That we have to calculate here, and that we have to find here. Before that, we see some important theorem of this. Now the theorem first. Second theorem of this chapter: the acute angle theta between two lines with direction cosines L1, M1, N1 and L2, M2, N2 is given by cos theta is equal to mod of L1, L2 plus M1, M2 plus N1, N2. Now this is the formula and this is the theorem to calculate the angle between two lines. The theta is acute. Here the word is acute. Acute angle less than 90 between two lines with direction ratio. The first line direction ratio is that L1, M1, N1, and second line direction ratios are L2, M2, N2. Then cos theta means angle between these two lines is L1, L2 mod of L1, L2 plus M1, M2 plus N1, N2. Now it is very short in proof. We can see the proof of that theorem first. Now this is angle theta. This is E1 cap. This is E2 cap. The line A bar, this is A bar and this is B bar. The A bar and B bar are the two lines. Theta is the acute angle between them. E1 cap is unit vector of along A bar. E2 cap is unit vector along B bar. Now proof. Let A bar and B bar are two vectors with direction cosines L1, M1, N1 and L2, M2, N2, and theta is acute angle between them. And E1 cap and E2 cap are the unit vectors along A bar and B bar. Therefore E1 cap is equal to, that is, first direction ratios L1 I cap plus M1 J cap plus N1 K cap. E2 cap is equal to L2 I cap M2 J cap plus N2 K cap. Now we can take dot of E1 cap and E2 cap. Therefore E1 cap dot E2 cap is equal to, we have L1 I cap plus M1 J cap plus N1 K cap into L2 I cap plus M2 J cap plus N2 K cap. So this is dot product, angle between two dot products is 1, unit value is 1, unit value 1, and that is cos theta is equal to, that is I dot I cap dot I cap, J cap dot J cap, and K cap dot K cap, its value is 1. Therefore L1 L2 M1 M2 plus N1 N2. So that is I cap dot I cap, J cap dot J cap is equal to K cap dot K cap is equal to 1. The properties of dot product. And next, this is, therefore cos theta is equal to the mod L1 L2 plus M1 M2 plus N1 N2. Because that angle is always positive, so we take here mod. So this is a simple proof of that angle between two lines, and theta is acute. That is hence the proof. If we have the direction cosines of line of two lines, then we can calculate the angle, acute angle between them. So that theorem is important too. If we have given direction cosines of two lines, then we can calculate the acute angle between them. So this will be also important theorem of to calculate the angle or to find the angle. Now if we have given remarks, write down remarks first. If there is no, suppose there is no direction cosines of lines, and we have given direction ratios, then how we can find the acute angle between them? So remarks is first. So remark first. If A1 B1 C1 and A2 B2 C2 are direction ratios of the lines A bar and B bar, direction ratio of line A bar and B bar, then this will be A bar is equal to A1 I cap plus B1 J cap plus C1 K cap, and B bar is equal to A2 I cap plus B2 J cap plus C2 K cap. Now let theta be the acute angle between them. Theta be the acute angle between them. Acute angle between them. Therefore, we have the angle of two vector product is dot product A bar dot B bar is equal to, we have mod A bar dot mod B bar into cos theta. Now A bar dot B bar, I cap, j cap, j cap, k cap, k cap, means this will be a1, a2, b1, b2, this is c1, c2, and that is mod of a bar. So mod a bar means magnitude under root of a1 square plus b1 square plus c1 square, and next under root of a2 square plus b2 square plus c2 square into cos theta. So this will be a1 a2 plus b1 b2 plus c1 c2. Take in denominator a1 square plus b1 square plus c1 square into under root a2 square plus b2 square plus c2 square is equal to cos theta. Now the angle is always positive, therefore cos theta is equal to, we take mod a1 a2 plus b1 b2 plus c1 c2 divided by a1 square plus b1 square plus c1 square into dot a2 square plus b2 square plus c2 square. This is the formula to calculate the angle between two lines if we have given direction ratios of that two lines. And that formula is, first we have seen formula cos theta is equal to mod L1 L2 M1 L1 L2 plus M1 N2 plus N1 N2. That is the formula if the direction cosines are given of that line. So that are the difference conditions. First if we have given direction cosine, and second we have given direction ratios. Now take the condition. Now we will see the condition of that two lines. Now first is conditions. Now first see with condition. For parallel and perpendicular lines, if two lines are perpendicular, then we know if two lines are perpendicular, then their angle will be 90 degree. So therefore cos 90 degree, the value of cos 90 is 0, and therefore cos theta is equal to mod L1 L2 plus M1 M2 plus N1 N2, and this is 0, so is equal to L1 L2 plus M1 M2 plus N1 N2, and that is we write L1 L2 plus M1 M2 plus N1 N2 is equal to 0. This is the condition if the two lines are perpendicular to each other, if we have given their direction cosines. Now next, if we have given their direction ratio, then what will be the, we write same as it is. If similarly, number second, if a1 a2, a1 b1 c1 and a2 b2 c2 are direction ratios of the lines, then direction ratios of lines are perpendicular, then a1 a2 plus b1 b2 plus c1 c2 is equal to 0. So this is the condition for direction cosines, and this is the condition for direction ratios if the two lines are perpendicular to each other. Now next, parallel. If two lines are parallel, then they make same angle with xyz axis respectively. Then they make same angle for xyz axis respectively. Therefore their direction ratios are same. Therefore the direction ratios are same. Therefore their direction cosines are same. That is, L1 is equal to L2, M1 is equal to M2, N1 is equal to N2. If two lines are parallel, then they make same angle xyz axis respectively. Then direction cosines are same. And similarly, if A1 B1 C1 and A2 B2 C2 are direction ratio of parallel line, then A1 divided by A2, B1 divided by B2 and C1 divided by C2 are proportionals. Now that are the important conditions to find the angle between these two lines. Now what we see here, if first condition for perpendicular line, if the two lines are perpendicular to each other, then L1 L2 plus M1 M2 plus M1 M2 is equal to 0. And if we have given direction ratios of that line, then A1 A2 plus B1 B2 plus C1 C2 is equal to 0. If the lines are parallel, then they make same angles alpha x y z axis. Therefore the direction cosines are same. L1 is equal to L2, M1 is equal to M2, L2. And if the direction ratios of that line are parallel, then their A1 proportion A2 is equal to B1 is equal to B2, C1 is equal to C2. So that are the required conditions to lines perpendicular and parallel. Now we will see next example of that all cases. Now first example we will see, find the acute angle between the first example we will see, find acute angle between the lines whose direction ratios are 3 to 6 and -2 1 2. So this is one of the important example, because from this we have to find the acute angle between them. So here we have given first direction ratios, not here we have given direction cosines. So here we have to use the next formula of cos theta is equal to mod A1 A2 plus B1 B2 plus C1 C2 divided by mod of under root A square plus B square plus C square into under root of A2 square B2 square plus C2 square. Now how we can solve it? Let the direction, let theta is the acute angle between them, acute angle between the line. Therefore we use the formula here, cos theta is equal to mod A1 A2 plus B1 B2 plus C1 C2 divided by a1 square plus b1 square plus c1 square into next a2 square plus b2 square c2 square. This gives equation number first. Now we calculate numerator and denominator first and put them value in equation number 1, and we get the required angle, required acute angle between these two lines. So how we calculate it? So listen carefully. Now, so what will be here? A1 A2 plus B1 B2 plus C1 C2. So here that 3 2 6 are the A1 A1 B1 C1, and that minus 2 1 2, that are the A2 B2 C2. Now here A1 A2, that is A1 is 3 A2 minus 2 plus 2 minus 1 2 minus 1 plus 6 2. So this will be 6 minus 2 plus 12. So this is 18 minus 2, so that is 16. That is A1 A2 plus B1 B2 plus C1 C2 is equal to 16. So this gives equation number first. Second, sorry, this is a plus 1. So here minus 2, that is minus 2 minus 6. So this is minus 6 plus 14, so this is 8. Now for second, similarly we can calculate this. A1 square plus B1 square plus C1 square is equal to, so this is, what is A1? 3 square plus 2 square plus 6 square, so is equal to under root 9 plus 4 plus 36. So this is the under root 49, and this is 7. And last, and under root of A2 B2 C2, A2 square plus B2 square plus C2 square is equal to, so here is minus 2 square plus 1 plus 2 square. So this is 4 plus 1 plus 4, so this will be 9, that is 3. Therefore we put the all values of this equation number 1. Therefore equation 1 becomes, now equation 1 becomes, what will be the equation 1? Equation 1 becomes cos theta is equal to mod, the first numerator is 8, second first denominator is value 7, and next value is 3. So this is the mod of 8 divided by 21. Cos theta is equal to, and therefore theta is equal to, take it inverse, cos inverse of 8 by 21. So this is the required acute angle between these two lines if we have given the direction ratios of that line. So it is very easy to find the direction ratios of any two lines if we have given direction ratios. So many examples we have solved, such like as, now next example we will see We see this example for conditions just like parallel, perpendicular, as like. Find K if triangle ABC is right angle at right angle at B, where A is equal to, where A 564, B 441, and C 82K. Now this is one of the important example, because here we have to use the condition of perpendicular lines. So we first draw figure. Now here we give a triangle ABC. Triangle ABC is right angle triangle at B, means ABC, this is right angle triangle, and that ABC are the coordinates of that points. Therefore A 5 6 4, B's 4 4 1, this we say, and C 8 2K. We say x1 y1 z1, that is x2 y2 z2, and this is x3 y3 z3. Now these are the coordinates of that point A, B, and C. B is right angle at that point. Now we have to find the value of that K. That K is missing point, and this is the, here is K, we have to find. Now first, what can I do for here to find the value of K? Are you guess some how we can do here to find value of K? Which conditions we will use here? Listen here, we know that AB is perpendicular to BC, means there are two lines perpendicular to each other. Okay, so we first, now we have to find the direction here the line AB and BC are perpendicular to each other, Now then we can find the direction ratios of that AB line. Next, direction ratio of that BC line. Therefore the direction ratio of ABR, x2 minus x1, y2 minus y1, z2 minus z1. So that is 4 minus 5, that is 4 minus 6, and this is 1 minus 5, 1 minus 4, this will be minus 1, this is minus 2, and this is minus 3. So here, therefore, A is equal to minus 1, B is equal to minus 2, and C is equal to minus 3. So that are direction ratios of the line AB. Similarly, we can also find the direction ratios of the line that AB. So therefore, the direction ratio, next, the direction ratio of line BCR, therefore direction, similarly direction ratio of line BCR Now here x3 minus x2, y3 minus y2, z3 minus z2. Put the values. So 8 minus 4, this is 2 minus 4, k minus 1, so this will be 4, this is minus 2, and that is k minus 1. So that are the direction ratios of that line BC. Now we find direction ratio of AB line and direction ratios of BC line. We say here A1, B1, C1, and here we say that A1, A2 is equal to 4, B2 is equal to minus 2, and C2 is equal to K minus 1. Now we know that if the two lines are perpendicular to each other, then we have a condition A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So therefore, we have A1, A2 plus B1, B2 plus C1, C2 is equal to 0, and this will be A1, A2, A1 minus 1, A2 4, B1 minus 2, B2 minus 2, C1 minus 3, C2 K minus 1 is equal to 0. So this is minus 4 plus 4 minus 3K plus 3 is equal to 0. Now we get required answer. So that 4 get cancelled. So minus of 3k plus 3 is equal to 0. Now minus 3k is equal to minus 3. That is k is equal to 1. Hence k is equal to 1. Hence the result. Hence the result. Now such type of examples very important. If their direction ratios not given, but the figure is given which represent there which angle is a right angle or not, and from that we can calculate the value of that k. Now next important example, as like in short we can write find x. Third example, similarly as like find x. If triangle ABC is right angle at A, is right angle at A, where A 4, 2, 3, B 3, 1, 8, and C x minus 1 and 2. Now this is the also important example. What is the difference between first and that example, this example? Here is also right angle. The difference is that in first example there is B vertex is right angle, here A vertex is right angle. That in triangle ABC, that A is at right angle. So here we can see, take here A, B, C. At A point this Triangle is right angle triangle. Now that are the vertices of point A, B and C. Let A is equal to 4, 2, 3, B 3, 1, 8, C X minus 1, 2. We assume it x1, y1, z1, x2, y2, z2, and here x3, y3, z3. Similarly, just as it is, we have AC is perpendicular to BC. AC is perpendicular to BC. Now, AC is perpendicular to BC. AC is perpendicular to BC. Now, what happened? Therefore, first we have to find direction ratio of AC, direction ratio of AC. Then we can find direction ratio of AB. So therefore, x2 minus x1, y2 minus y1, z2 minus z1, that is AC x3 AC, A or C, means here A and this is C. First point is A and second is E, that is A means here x1, y1, z1, and C means here x2, y2, x2, y2, z2. Now AC. So this is x C minus 4 minus 1, that is minus 2. This is 2 minus 3. So this will be x minus 4 minus 3 minus 1. Therefore, A1 is equal to x minus 4, B1 minus 3, C1 is equal to minus 1. Now, next we will find direction ratio of AB. Direction ratio of AB are x2 minus x1, y2 minus y1, z2 minus z1. So this becomes x2, that is 3 minus 4, 1 minus 2, 8 minus 3, that is minus 1, minus 1 and 5. Therefore, A2 is equal to minus 1, B2 is equal to minus 1 and C2 is equal to 5. Now we have that two lines are perpendicular to each other. Therefore, we have A1, A2, B1, B2 plus C1, C2 is equal to 0. So what is this? A1 x minus 4, A2 minus 1, B1, B2, that is minus 3, minus 1, C1, C2, minus 1, 5 is equal to 0. So this is minus x plus 4 plus 3 minus 5 is equal to 0. So this is minus x plus 7 minus 5 is equal to 0, minus x plus 2 is equal to 0, x is equal to minus 2 and x is equal to 2. So therefore the value of x is equal to 2. So such type of examples we can solve by using conditions of direction ratios or direction cosines of that given lines. So okay, we shall stop here and we finish our chapter.